Welcome to Peer Learning Channel. Today we'll have a small session on fundamentals of cloud. I am Sabyasachi Samadar who will take this session. So we'll start with a small brief introduction about myself. I'm Sabyasachi Samadar. I've done MTech in computer science and professionally I'm a cloud solution architect. If you want to follow me, you can go through my LinkedIn profile and you can drop me any email if you have any queries in my personal email ID. So let's come to the agenda of this session. Today we will go through like why cloud, what is cloud, then different types of cloud providers, different aspects of cloud, and then a bit of a future of cloud. So why cloud? So before cloud computing, we had traditional computing, and the traditional data centers consist of various pieces of hardware, such as a desktop computer, which are connected to a network via a remote server. This server is typically installed on the on-premises and provides all employees using the hardware access to the business stored data and applications. Businesses with this IT model must purchase additional hardware and upgrade in order to scale up their data storage and services to support more users. Mandatory software upgrades are also required with traditional IT infrastructure to ensure fail-safe systems are in place to in case a hardware failure occurs. For many business with IT data centers and in-house IT department is needed to install and maintain the hardware. On the other hand, traditional IT infrastructures are considered to be one of the most secure data hosting solutions and allows us to maintain full control of our company's applications and data on the local server. There are a customized dedicated system ideal for organizations that need to run many different types of applications. So if you come to see the difference between a traditional computing and a cloud computing, you'll find that the main headache of traditional computing was maintenance of the infrastructure. Apart from that, if you want to expand your business, then flexibility was not there. So scaling is another big challenge. Outages are really difficult to maintain. So if one of your region goes down, up your business in some different region and purchase servers and maintain all those hardwares in a different region from scratch, uh, it should take months. So your application becomes like down for months, and that was never good for the business. Then disaster, the way I told, like disaster causes significant loss of availability and resources. Then security was self-driven, and like policies need to be updated frequently, and it's good if you know what kind of compliance you need. But sometimes what happens when you go to a different country which is unknown to you, you need to aware of the government policies and the compliances. It becomes another challenge for big enterprises, multinational enterprises, to create their own business in different countries or unknown countries where they don't know the laws much. So that then you need to hire a special security specialist to help you on those grounds. Apart from that, we have big infrastructure and admin team to maintain, and that actually cost a lot of your business expenses. Then resources are not efficiently utilized. So these are the main challenges traditional computing used to have. And in cloud computing, if you see, it's a kind of a pay-as-you-go model, and it facilitate only pay of resources which has been used. Then scaling is easy without any significant downtime to the business. Now, scaling, what I want to mean here is like scaling out and not scaling up. I will give you the difference between scaling up and scaling out in the next slides. But keep in mind that scaling out is always easy, but if you go with scaling up, there was always a downtime associated with it. So then flexible disaster recovery strategies and high availability policies that comes with cloud computing. Then enterprise level data protection, and I think all the cloud providers currently have the compliances ready, which helps you to be security compliant wherever you are deploying your business resources. And then with cloud, your IT stuff and admin costs get reduced, so that is also another big positive. So these are the reason why people are moving to cloud computing. And if you really want to scale your business, cloud computing is a no brainer. So let's go to what is cloud. By definition, cloud is a platform through which users can receive different types of services through internet based on the consumption plan selected. It's divided into two types of model, and one is a deployment model, which consists of public cloud, private cloud, and hybrid cloud. And then we have service models where we have infrastructure as service, platform as service, and software as service. But there are other forms of service also, but we will stick with this three types of services in this session. Let's go to the next slide. Then here we have explained the deployment models with a kind of an example. So public cloud, private cloud, and hybrid cloud. So public cloud is something like which is open for public, and it's you can relate it as an hotel where you go and you use the resource as a pay as go service model, and uh, you don't need to think about the security of that model, and you're not owning those resources. So those resources owned by someone else, you are just using it based on your need, and then you can delete them whenever you're done with your need. And private model is something like you private cloud, you own that cloud, or it's similar to a own house kind of thing. So where you own all the resources, you own the whole infrastructure of your cloud, and whatever you deploy, you need to maintain it. And that is something called private cloud. You need to maintain the security. Obviously, the security providers, all the cloud providers will provide you the proper security measures, but you need to configure them and use it accordingly. Hybrid cloud is kind of you can relate it as a rented house, where you have the benefits of the both the world, public and private. So you can choose and select which resources you want to make it public and which resource you want private, which will be only for your organization to use, and which will be kind of open for other resources to use, like other users to use. Like in a company, there can be internal users as well as external users. So external users can use the public resources, and the internal users can use the uh, private resources. So that is the hybrid model. Then comes the service model. So here we have three different services: infrastructure service, platform as service, and software as service. So let me explain you these services one by one. I think we all got an idea about what is on-premise is all about. Let's talk about the infrastructure service. So, cloud infrastructure service, known as infrastructure service (IaaS), are made of highly scalable and automated compute resources. IaaS is fully self-service for accessing and monitoring computers, networking, storage, and other services. Okay, so IaaS allows business to purchase resources on demand and as needed instead of having to buy hardware outright. So the delivery model of this IaaS is like it's cloud computing infrastructure. Okay, so it's including servers, network, operating system, storage through virtualization technologies. So these cloud servers are typically provided to the organization through a dashboard or an API, giving IaaS clients complete control over the entire infrastructure. IaaS provides the same technologies and capabilities as a traditional data center without having to physically maintain or manage all of it. IaaS clients can still access their servers and storage directly, but it is all outsourced to a virtual data center in the cloud. As opposed to SaaS or PaaS, IaaS clients are responsible for managing aspects such as applications, runtime, OS, middleware, and data. However, providers of the IaaS manage the servers, hard drives, networking, virtualization, and storage. Some providers even offer more services beyond the virtualization layer, such as database or message queuing. So, what's the advantage of this IaaS layer? IaaS offers many advantages, like, for example, the most flexible cloud computing model, easy to automate deployment of storage, networking, servers, and processing power. Hardware purchases can be based on consumption. Clients retain complete control of their infrastructure. Resources can be purchased as needed, and it is highly scalable. Okay, so let's go to the PaaS model now, and you can see the number of options gets reduced as managed by the owner. Only application and data now you can manage. So it's another platform service which helps you to provide cloud components to certain software while being used mainly for applications and data. So PaaS delivers a framework for developers that they can build upon and use to create customized applications. So all servers, storage, and networking can be managed by a enterprise or a third-party provider, while the developers can maintain management of the application. So PaaS provides a platform for software creation. So this platform is delivered via the web, giving developers the freedom to concentrate on building the software without having to worry about the operating systems, software updates, storage, or infrastructure. PaaS allows businesses to design and create applications that are built into the PaaS with special software components. This application, sometimes called middleware, are scalable and highly available as they take on certain cloud characteristics. So the main advantages of PaaS are they are very simple: cost-effective development and deployment of apps. They are very scalable, highly available. Developers can customize apps without the headache of maintaining the software, and then a significant reduction in the amount of coding needed. Then automation of business policies and easy migration to a hybrid model. Now let's come to the SaaS part. So software service, also known as cloud application services, represents the most common utilized option for business in the cloud market. So SaaS utilizes the internet to deliver application which are managed by a third-party vendor to its users. A majority of SaaS applications run directly through your web browser, which means they do not require any downloads or installation on the client side. So, due to its web delivery model, SaaS eliminates the need to have IT staff download and install application on each individual computer. With SaaS, vendors manage all potential technical issues such as data, middleware, servers, and storage, resulting in streamlined maintenance and support for the business. So the main advantage that we can get with SaaS is like it provides numerous advantages to employees and companies by greatly reducing the time and money spent on tedious tasks such as installing, managing, and upgrading software. This frees up plenty of time for technical stuff to spend on more pressing matters and issues within the organization. Okay, so then let's go to the different types of cloud providers. So I just list down the top 10 cloud providers that we have. This I've not ranked them up, so you must be aware of this cloud provider. So whenever you select a cloud provider, you need to go through this top 10. Mainly Azure, AWS, and Google are the main leaders of cloud. We have the other are also kind of coming up with a lot of new features, and the cloud war is going on among this top 10. There are more cloud providers, but just you can stick with this 10, and I think it will be okay for you to take a good decision of choosing a proper cloud provider. Okay, so let's talk about the different aspects of cloud. So these are the three different aspects I thought of discussing with you today. One is scaling, one is high availability, and one is serverless. So what is scaling? Scaling is like there are two types of scaling that we'll talk about today. It's like one is horizontal scaling and one is vertical scaling. So horizontal scaling is scaling out and scaling in. Okay, so it means like you can add more instances of your resources, that is scale out, and you can reduce them, that is scale in. Okay, now to implement this, you don't need to down your application. So in cloud you can scale out and scale in without having any downtime to your application. But vertical scaling is like making your infrastructure big with the upgrade you can talk about. And whenever you go with the scale up option, there is a significant downtime. So think twice before going for a scale up option. It's better to know the configuration of your default device before you deploy your application, and then go with scale out so that your applications are not down anytime. And then still the scale up option is always there, but keep in mind that there will be a downtime associated with it. So let's go to the high availability. This is a small example of high availability. So you can see from this diagram is like it's the cloning of your application. So multiple instances of your application or your resources should be there, and this is way in cloud you can make it highly available. So think of a scenario where in different cloud providers define this high availability differently. So for example, there is a concept called availability zones and availability regions. Okay, and So availability zone means resources can have have the property to clone itself twice or thrice, and whenever anything happens to your primary resource, the secondary resource pops up and can be available for you for consumption. There is a concept called regional duplications, where you can duplicate your instances in different regions. So one of your if one of your region goes down, you can still get the services from a different region. So that is the main concept of high availability, and this is really one of the key features, where whenever you design your cloud architecture, your high availability should be properly mentioned, so that even the client gets an idea about how those resources are highly available in case of disasters. Now let's talk about serverless. So serverless computing is a computing framework which helps to deploy code or business user flows without worrying about the computing infrastructure. It auto scales on demand, and ideally they are charged based on the consumption. So it reminds me similar to a PaaS kind of model, where you don't need to think about the infrastructure, but you just need to deploy your code and data and your user flow, and then the serverless component will take care of that. The benefits that it get is like it reduce the cost, because you don't need to worry about the resources when it is not running. You're not going to charge for that. Whenever you're consuming that resource, you'll get charged. And apart from that, auto scaling happens by default, so you don't have to worry about auto scaling. It is easy to maintain, the serverless components are really easy to maintain, and fast deployment happens. So these are the main key advantages of serverless features for cloud. Now let's go to the future of cloud. For future of cloud, it's uh, you'll find down the line there will be more speed and more storage coming up. There will be new innovation, mainly for in the artificial intelligence and the machine learning forum, and all the cloud providers are working on it. Then there will be more transparency in the cost management, so people will kind of get more clarity about how much they are paying for which resource. uh, Application hosted in your cloud will have more availability. I can remember, like, when cloud came into being, and if I compare that with today's high available options, it has improved a lot, and down the line it's going to improve more, as we are going with more in codeless technologies. uh, and then it will be our future workforce. So any enterprise who wants to scale and wants to grow, they needs to bring at least one cloud provider in their workforce, and that will be part of our daily life. So this is kind of the future of the cloud. So that's it from me. Thanks for tuning in.